Assalamualaikum. My name is Siti Nur Aliza binti Azmi and this is my ID number EA18T20. And today we're going to talk about push and pop instruction. What is push instruction and what is pop instruction? These two instruction works on stack memory. Then before we going through the details of how push and pop instruction works, let us get to know a little about memory stack. Okay, memory stack is like a temporary memory for register. One of the essential elements of stack memory operation is a register called the stack pointer. Stack pointer indicates where the current stack memory location is and is adjusted automatically each time a stack operation is carried out. In common terms, storing data to the stack is called pushing using the push instruction, and restoring data from the stack is called popping using the pop instruction. Let's say we're moving into a microcontroller and it is organized something like this. Here we have the higher end and the lower end. So in our microcontroller, push and pop are commonly used at the beginning and at the end of a function or subroutine. At the beginning of a function, the current contents of the register used by calling the program are stored onto the stack memory using push operations. And at the end of the function, the data on the stack memory is restored to the register using pop operations. In a simple words, data will be pushed into the stack with push instruction and then it is going to be recovered by pop instructions into the register. Okay, for a clear explanations of push and pop instruction, I pass this presentation to my group member Izwan. Thank you.
Assalamualaikum and good day everyone. My name is Muhammad Izwan Usaidi bin Ismail and I'm going to continue the presentation of stack operation. So as we know in here, the stack operation have only two syntax, which is push and pop. So let's jump into the first syntax. So basically the first syntax is push. So push curly bracket RA RB RC is up to 8 bit. Just we use the low register R0 until R7. Then push store single multiple register. Single or multiple, we can only use single register or multiple register. So into memory and update stack pointer. So the stack pointer points to lowest push data address. So if you look into this image right here, so the old stack pointer points to the latest data inside the stack pointer. So this is where the stack pointer points before the push operation done. So after the push operation done, the stack pointer will point into the latest data that inserted. Like this one is R5. So the stack pointer is pointing to that R5. So what happened into the memory? So let's say if the RA, the location of RA is hexa 04, then RB should be hexa 08. So the difference between them is 4 bit. So that's the difference between them. So stack pointer, the last store address. So this is stack pointer points to the last store address. So the pop syntax is similar to the push syntax. We use low register list R0 up to R7, and pop retrieve single or multiple registers. So, yeah, same like push syntax. So it can use low register and program counter. So push push we use low register and LR, and that's a low register. So from memory and update stack pointer, so stack pointer points to the last emptied stack. So if we look into this image here, so the old stack pointer is pointing to the empty slot, which is R0. This R0 is basically after the pop operation. So if old SP points to the latest, I mean the last empty stack plus 4. So plus 4. So the hmm, alright. So the after the pop operation done, the stack pointer will points to the last data plus 4. Plus 4, which is the box upper them. So this empty box, right? So that's where the stack pointer will point. So inside the memory, so RA memory SP. So if the location of RA is hexa 004, let's say, and RB will be hexa 08 because the stack pointer plus 4. So the stack pointer, the last restore address. So this is the where the pointer will point. So the empty slot. Alright, that's all from me. Alisa will continue the presentation. Thank you.
Hi, my name is Alisa Afifa binti Amir, and I'm going to explain about the restriction in push and pop instruction. For push and pop instruction, the register list that can be used only from R0 to R7. But there is an exception for push instruction, which is we can use link register, while for pop instruction we can use program counter register. As for the condition flags, this instruction do not change the flags, so the value of flags is not significant at all. For simulation in Kill software, my friend Lai Chongjin will explain more detail about push and pop instruction. That's all from me. Thank you very much for your attention.
Assalamualaikum. My name is Muhammad Zulfikri, and I'm going to continue to share about the push and pop instruction by doing the coding. Okay, this is the example of the coding. Okay, we start here. This is move register 0 to 12 in hexa. Okay, we see at here. Okay, then continue, and then we add and move. Okay, here you see R0 until R6 have data, and this is the instruction of push. So this part is a condition. We refer to the kill website. Okay, there is this is the syntax here, that push condition the register list. Okay, the condition, this is the optional condition code. Okay, this is the optional condition code, and this is the register list. Okay, this is the register list. R4 until R7 we will stack to the stack point. Okay, we start here. Okay, we see the stack point is changing to this data. That means it has been stacked here. And pop is the instruction to stack up the stack into the register list. And I put the register list at R6, and we tab here. See the data has been stacked up from this to R6, and I'm going to show you that the register the push. Okay, we start first. Okay, the register can only until R7, R0 until R7. If we put R8, it will be error there. Okay, you see there's an error. So until R7 only. So there's no error. Okay, that's all for me. Thank you very much.